to the next video in our geometry series. Today's topic is going to be back on triangles, but this one is going to be trigonometry. So SOHCAHTOA. You might have heard this before, but what this means is it's an abbreviation for figuring out the relationship between angle measures and side lengths of right triangles. And these do not have to be whole numbers, but they use functions called sine, cosine, and tangent. So the O means opposite. The H means hypotenuse. And the A means adjacent. So what this acronym means, SOHCAHTOA, so if we take just this piece right here, sine of theta, so if we take an angle measure theta, and it has to be not the right angle, so any other angle on a triangle, sine of that angle theta is equal to OH, opposite over hypotenuse. So the second letter goes on top, the third letter on the bottom. CAH, C-A-H, that means the cosine of theta is equal to A over H, so adjacent over hypotenuse. And then finally, TOA, T means tangent of theta, is equal to O over H, opposite over hypotenuse. So if we take this angle theta right here, the opposite side is going to be over here. The adjacent side is right next to the angle, and the hypotenuse, as always, is opposite the 90-degree angle. So let's get into a few examples. The first example we have is a right triangle, obviously, and then we have a side length of 10, an angle measure of 25 degrees, and we're trying to figure out what the length of the hypotenuse is. So if we look at any right triangle, we're talking about trig, the first thing we do is we figure out which angle measure we're referencing. In this case, we have one angle measure right down here in the bottom corner. So we look at what the pieces of information we're given are in relation to that angle measure. So one side length is opposite, so we have an O, and then the other side length we're looking for is the hypotenuse, so that's an H. So if we look for any of those acronyms, we're looking for one with an O and an H. So SOHCAHTOA. Here we have an OH, here's an AH, and here's an OA. Well, obviously, sine is opposite of hypotenuse is what we're going to be using because there's an OH there. So sine of 25 degrees is equal to opposite over hypotenuse. So 10 over x. From here, we simply reorganize this and solve for x. So we're going to multiply by x on both sides and divide by the sine of 25. And we get that x is equal to 10 over the sine of 25. And if you plug that into your calculator, make sure you're in degrees and not radians. For your mode, you're going to get something along the lines of 23.66. So not too bad. These are definitely calculated problems. The next example we have is one side length here of x, another side length here of 2, and we're given the angle measure of 65. So again, we look at our angle here, and we figure out what information we have relative to that angle. X right here is adjacent to 65, and 2 is opposite. So looking back at this acronym here, we're going to use tangent, opposite over adjacent. So tangent of 65 degrees is equal to opposite 2 over adjacent x. And then we'll use the same simplification as the last time, multiply by x, divide by tangent of 65. And we get that x is equal to 2 over the tangent of 65 degrees. And that gives us roughly 0.933. And then one last example here with sine. We are going to have an angle, or a side length, I apologize, of x right here, an angle measure of 32, and a hypotenuse of 6. So we have our angle measure 32, we have opposite over here and a hypotenuse over there. So sine of 32 is equal to x, the opposite, over 6, the hypotenuse. And this one's a little simpler. We'll just multiply both sides by 6. And x is 6 times the sine of 32, which gives us roughly 3.18 as our side length. So that's regular sine, cosine, and tangent. There is something that happens a few times occasionally where we can't directly solve for a side length. Now, if we want to solve for an angle, let's see what happens. We'll take the example of we have an angle theta. It's a right triangle, and we're given the opposite side has a length of 4.7, and the hypotenuse has a length of 9. Well, we can see this, and we see that we're using an opposite, hypotenuse, and angle, so sine of theta is equal to 4.7 over 9. Well, here we're kind of stuck. We can't simplify this anymore. You can't divide by sine and get theta by itself. We can't multiply by 9, divide by 4.7. All the numbers are on one side, and then our variable theta is on the left hand out of the equal sign. So what do? Well, there is something called inverse trig. And what inverse trig is it's the opposite of a trig function. So, for example, sine theta, we can do inverse sine. And remember, in any sort of algebra, what you do to one side of the equal sign, you have to do to the other side of the equal sign. So we can take the inverse sign, and that's denoted by sine to the -1 of sine theta. And then we'll also do the inverse sine of the other side, 4.7 over 9. And the inverse sine and the sine are inverses of each other. They negate each other, which means those basically cancel out. And we're left with theta is equal to the inverse sine of 4.7 over 9. And on a calculator, on a TI-84 and most TI series, you hit the blue second button, and then you hit sine, and you get inverse sine, which is the sine to the -1 right above it. Similarly, for inverse cosine is second cosine, and inverse tangent is second tangent. And if you plug that into your calculator, you're going to get something 31.48 degrees roughly. One last example here. We're given an angle theta that we're solving for. One base is 4, the other base is 15. Here we're going to use tangent because we have an opposite and an adjacent. So tangent of theta is equal to 15 over 4. Again, that's as simple as we can get it with just regular algebra. But if we use our inverse trig function of inverse tangent times tangent theta equals inverse tangent of 15 over 4. The inverse and the regular tangent cancel out, and we get that theta is equal to the inverse tangent of 15 over 4, which gives us a value of 75.06 degrees. So regular tangent, regular sine, regular cosine, your trigonometric functions, they work great for given an angle measure and a side length, solve for the missing side length. Inverse trigonometric functions, inverse sine, inverse cosine, inverse tangent, they work great for going from side lengths to an unknown angle measure. And once again, we'll just review that the actual abbreviation is SOHCAHTOA. So SOHCAHTOA, SOHCAHTOA. That's a pretty easy one to remember. Use it a few times, practice with it, and you'll get it down great. So thank you again, and I'll see you on the next video.